Hi, my name is Sebastian Matteau, and today I would like to tell you about properties, class methods and static methods in Python. Now, these are all particular kinds of ways to change the behavior of methods or functions in class definitions. They are decorators. Now, let's get to work. The class that we're going to use is a class called trap_artist that represents a trap artist. I will first define this class in a way that is just basic object-oriented programming, and if you've ever done any object-oriented programming, this will look very familiar, right? So I create an init function, and it takes a name. Our trap artist so far only has a name, and we assign this name to underscore name, the underscore name property of the object. Now, why underscore name? Because it's a Python convention that if you have an object property that you don't want anything outside of the object to access, you prefix an underscore, right? And then what we do is we create a getter object name, and what the getter function name, and what it does is simply return self.name, right? So instead of assigning and getting underscore name directly, we assign through the constructor and we get it through this getter function name. And what we can do then is create an instance of a trap artist, right? So far, nothing special. Say Rick Ross. And what we can then do is print rr.name, right? Up. And then what we will get is Rick Ross. Now, this works, but we can make it a little bit more elegant by using our first trick, namely a property. So what we can do is change this name getter function into a property simply by applying the property decorator. What this does is it changes the semantics of the function in such a way that we don't need to explicitly call the function anymore. We can simply refer to it. So we can remove the parentheses behind name and it will still work, right? So now from an outsider perspective, it's completely transparent that name is actually not just an attribute of the object, but it's actually a function, right? Because we can now refer to the function as though it's an attribute. That's what the property does. Now, we can also, this is a getter property. We can also create a setter property that allows us to change the name, and we can do it as follows. We say add, then name, and this name here refers simply to our name property here, right? They're the same thing. And then .setter, and then what we say is def name, self.name. So essentially our setter function takes one argument, namely the new value, and then we say self._name is name. This is our setter function, our setter property. Now, how can we use it? Well, we can simply use it by saying, for example, say that Rick Ross, as he sometimes likes to do, wants to change his name to Ricky Rose. Then we can do this as follows, right? So we can rename Rick Ross to Ricky Rose like this. And from an outsider perspective, it's completely transparent that we're actually calling these setter and getter functions rather than directly accessing some kind of underlying property or attribute of the object. Now, why would we want to do that? Well, we could use that, for example, to validate the input. Say that we don't just simply consider anyone a trap artist. We have a list of predefined registered trap artists. Now, this list contains obviously Rick Ross, but it also contains, for example, future, designer, and we'll throw a young Jeezy in the mix. Now, and then what we can do here in our setter function, we can say, okay, if name not in trap artists, right? So then what we do is we raise a value error because then name has an incorrect value. And then we say raise value error up is not a trap artist name. Now, once we've done this, our second renaming should fail, right? Because Ricky Rose is not a registered trap artist here. So if we do this, you see it will work. It will raise a value error. Ricky Rose is not a trap artist. Whereas, for example, if we would rename Rick Ross to Future for whatever reason, that would work because Future is a registered trap artist. Now, so here we take control over basically what is allowed to be set as a name, right? So the setter and getter properties are really very convenient. Now, let's move on to another trick, the so-called static method. A static method is created simply by applying the @staticmethod decorator to a method that you want to make static. Let's say random artist. Pause. What is static about this method? Well, you see that it does not take self as a first argument, right? So all other functions, all normal class methods take self as a first argument, and that self refers to the instance of the object that we're working with. A static method doesn't have that. So a static method is simply basically a normal function, but it is attached to a class definition, right? So we might as well have defined our random artist simply at the top level and not make it static. But if we like to sort of semantically or conceptually bind our random artist function to our class definition, we can do it as follows and create a static method, right? Now, so we don't need an instance of our trap artist. We don't need a trap artist object to call our static method. Simply the class is enough. And what are they good for? Well, static methods are often used to implement factory functions. And factory functions are functions that generate an instance of the class. So they generate objects. Here our random artist is a factory function that's going to return a random instance of a trap artist. So for example, return trap artist. And what is the name? The name is going to be random.choice from our list of trap artists. And then we need to, of course, import random here. Now, how can we use our static method function? Well, we can simply say TA is a trap artist dot random artist, right? Because we don't need to create an instance of trap artist. We can simply refer to the class and then dot random artist, and that's enough. That allows us to access our static method. And then we should get a random trap artist, right? See if it works. First we get Rick Ross, future, designer, etc. Right? So this use of a static method happens you will see it every once in a while, and it's called a factory function. Okay, now let's move on to our final type of decorator, and that one is conceptually a little bit more difficult to wrap your head around, and also a little bit more complicated to use correctly. It's a class method. And as a class method, say that we have a hits CLS. And then we say, I'll just type it, and then I will explain it later. CLS.hits. So I will add an underscore hits property to our trap artist class. And it will be just a list of general trap artists, general trap songs. So Dead Presidents, Panda, and Money. I can't imagine that there is no trap song called Money. I don't actually know any, but I imagine there is one. And then what we do here in our class method, we refer to this underscore hits property of our class. Now you will notice that our hits class method takes a CLS as a first argument and not a self. And this CLS refers to the class. So it refers to not an instance of trap artist, that would be self, not one specific trap artist, but just the general trap artist class. And because this underscore hits properties is a property of this general, it's part of the class definition, we can refer to it here. Now then what we can do is something like this. We can say, for example, okay, if we want to have a list of trap songs, we can say trap artist dot hits, and we can print it out like this. Oh, name error, trap artist, right? And we get Dead Presidents, Panda, and Money. You see that we don't need to create an instance of a trap artist. Again, we can simply refer to the class and then right away call the .hits function. So a class method is in a way sort of in between a normal method, which takes an instance, self, and a static method, which is essentially completely separated, completely distinct from our from the class, right? A class method is linked to the class, but it's linked to the class definition and not an instance. Now this works, but you can get quite strange behavior if you don't fully understand what you're doing. Let me illustrate this. For example, we have Rick Ross. We say, okay, we create a trap artist, Rick Ross, and then we print out rr.hits. Now, again, of course, it's not terribly surprising. We have not specified any hits for Rick Ross. So what we get is just this generic list of trap hits, which are not all hits by Rick Ross. So then you might think, okay, let's let's change the hits. So we say rr._hits is, and then we say, okay, Rick Ross has a hits called Purple Lamborghini, for example, and also a famous song called Trap, Trap, Trap. Now, print this out, and then you say, hey, wait, it looks like we changed the _hits property, but when we print it out, right, through our class method hits, it actually still returns the old value. How is that possible? Well, what's happening here is that we now have an _hits property of two different layers of our object. We have at the class, as part of the class definition, we have this list right here, which we haven't changed. And then our instance, namely Rick Ross, also has an _hits property, and that's this one. And our hits class method refers to the class definition _hits and not the _hits of Rick Ross. What we could do is, for example, we shouldn't do that because it's very poor programming style, but we could do it to illustrate a point. Change the _hits property of the class like this, right? And now you see it works. So what we're doing now, by assigning to the _hits property of the class, we are actually changing this. And that's what our class method refers to, right? But if we're doing this, we're actually changing, it seems like a valid thing to do, but it's not. It changes the wrong _hits. So this illustrates that class methods can be convenient in some rare cases, I would say, but they can be, you can get confused between what is actually your class definition and what is your object, right? So what I would do in this particular case is not turn hits into a class method, but just have it be a regular method. And that will work as well, because even if we don't explicitly assign _hits to Rick Ross, Python will automatically look to the class definition and find an _hits there. But if we do change the _hits for Rick Ross, like this, you would see that it has the expected effect, namely it changes Rick Ross's hits to Purple Lamborghini and Trap, Trap, Trap. Okay, now that's what I wanted to illustrate today: properties, static methods, and class methods. My advice, my general bird's eye view advice would be use properties, getters, and setters a lot because they're pretty sweet and they allow you to write very elegant code. And be careful when using static methods and class methods because they can be useful, but they can also lead to buggy code. Thank you very much for watching.